In this video, we'll talk about heat transfer. First, we need to talk about thermal conductors and thermal insulators. And we've already mentioned this a little bit when we talked about barriers and ability to move heat easily when we talked about the zeroth law of thermodynamics. So a conductor is a material that allows heat to flow easily or to transfer easily. Usually we're talking about metals. For insulators, they are materials that are slow or they block heat transfer. So wood, plastic, fiberglass, those are all good thermal insulators. We just defined thermal insulators and conductors. Now we're going to examine the mechanisms of heat transfer and the rates of heat transfer. The mechanism of heat transfer occurs three ways. There's conduction, convection, and radiation. As indicated earlier, temperature is directly related to the average kinetic energy of the molecules in a substance. In a warmer region of the object, so here we see it at temperature T2, the molecules have a higher average kinetic energy than in the cooler regions, which is in the object called T1. Conduction is the flow of heat due to the transfer of that kinetic energy from those molecular collisions within the objects. The rate of heat transfer, delta Q over delta T, depends on the following. It depends directly on the relative temperature of both objects, T2 and T1. If there's no difference in the two temperatures, there's going to be no heat transfer. It's directly related to the cross-sectional area available for collisions to occur. It's inversely proportional to the length along which the heat must pass. It's also directly related to the conductivity, which we call K, which is the ease of the heat transfer. So for materials that allow heat to transfer easily, which we call thermal conductors, they'll have a low conductivity. And if we have an insulator, then that will be a large number, a high number. Okay, so delta Q over delta T, which is the heat transfer, is equal to K, which is the conductivity, times the cross-sectional area of contact, divided by the length of the object, times the change in temperature, or the difference between the two temperatures of the two objects. So let's go ahead and do an example. An iron bar with a length of 1 meter and a radius of 10 centimeters is heated from the bottom by a lighter. If the bottom of the bar has a temperature of 35 degrees Celsius and the top of the bar has a temperature of 20 degrees Celsius, what is the rate of heat transfer through the bar? We're going to have a conductivity of 80 watts per meter Celsius degree. And here are your choices. Go ahead and pause the video now to solve the problem. Okay, so let's take a look at the answer. We should have gotten A, which is 37.69. Substituting the numbers into the equation, we end up with 37.69 watts. Now, why is it a watt? Delta Q is heat transferred, which is delta Q is J, divided by time. So joules divided by time is a watt. Two objects of different temperatures are separated by a wall. If the thickness of the wall is L and we double that thickness, the rate of heat transfer will be A, doubled, B, quadrupled, C, unchanged, D, cut to 1/2, E, cut to 1/4. Choose your answer now. Okay, so let's take a look and see if you're right. The correct answer is D. If L is doubled, then delta Q over delta T is going to be halved. Convection is the process where heat is transferred by the mass movement of molecules in gases and liquids from one place to another. Warm masses rise while cold masses fall. This mechanism is important not only for the examples shown below, but also for weather, ocean currents, and the transfer of heat inside stars. So here we see a diagram of the convection and gases. The radiator heats up the air, the hot air rises. As it goes higher and higher, it starts to cool off. As it cools off, the cold air sinks. We get the same thing in liquids on the stove. The heat here at the bottom transfers to the water at the bottom. That heats up, it then moves up, it cools off as it reaches towards the surface, and it starts to sink again. So go ahead and let's look at this multiple choice question. Convection can occur, A, only in solids, B, only in liquids, C, only in gases, D, only in liquids and gases, E, all of the above, meaning liquids, gases, and solids. Go ahead and choose your answer now. Okay, so let's take a look at the answer. The correct answer is D. Convection can only occur where the molecules of a substance are free to move translationally, and that only occurs in gases and liquids. So now let's talk about energy transferred through radiation. Radiation is energy transferred by what we call electromagnetic waves. You have directly experienced it as the warming you feel from the sun or sitting close to a fire. You will also learn later in the electromagnetic waves unit that radiation occurs in as radio waves, microwaves, visible, infrared, UV, gamma radiation, X-ray radiation. You do not need matter to transfer the energy using electromagnetic waves. It actually travels through a vacuum in space. The rate of heat transfer by radiation is given by the Stefan-Boltzmann equation. So delta Q over delta T is equal to E sigma A T to the fourth, where E is the emissivity. It's a number that ranges between 0 and 1 that increases with the darkness of the surface of an object. Here we have, this is sigma, which is the Stefan-Boltzmann constant. It is a constant, so it's always going to be 5.67 times 10 to the negative 8 watts per meter squared Kelvin to the fourth. And the A, capital A, is the surface area of the object. T, again, is the temperature. A block of ice has a temperature of 0 degrees Celsius and a surface area of 1 meter squared. What is the rate of heat transfer by radiation? Ice has an emissivity of 0.97. Go ahead and pause the video now and solve the problem. Okay, so let's take a look at the solution. If we substitute in the numbers, we end up with 305 watts, and that is C. When the temperature of a heater is doubled, by what factor does the radiating power change? Is it by 2, 4, 8, 16, or 32? Okay, so let's take a look at the answer. The answer is D. If you double T, notice that it will increase by T to the fourth power, which is 16. Which of the following is responsible for raising the temperature of water in a pot placed on a hot stove? Select two of the answers. Is it A, conduction, B, convection, C, radiation, D, vaporization, E, condensation? Okay, so let's see. Hopefully you picked the correct answers. You should have picked A and B. The water is in contact with the pot, which is heated by conduction, and then this heat is transmitted to the rest of the water by convection. In the next unit, we're going to talk about, in the next video, we'll talk about gas laws.